Hey developers! So interviewing as a self-taught developer isn't always easy. You end up having to talk to a lot of different people and you have to show your knowledge. And there's a lot of terms you need to know. So I went ahead and made this list of 10 terms that I think every self-taught developer should know. And actually, it doesn't matter if you're self-taught or not. You probably should know these terms in general. But the reason I mentioned this self-taught is because there was a Reddit thread the other day where this guy was interviewing tons of new developers for a junior position, and they couldn't answer these basic questions. And he mentioned many of the terms I'm going to list here in this presentation. So I just wanted to make this quick presentation just in case you are one of those people that don't know these terms. You should probably research it, and I'm just going to go over each one of them and the definitions of each, and just a quick idea of what they are. You know, obviously this is just a quick video, so if you want to deep dive into any of these things, there's tons of resources online. I pulled some of this information from Wikipedia. I pulled some of this information from different blogs I found. So this is these are great terms to start off with if you are starting to interview and you want to do some preparation. Course is presented by my sponsor, and that is my Create Awesome Vue.js Apps with Nuxt.js course. This is a 2 courses in 1 course, which is really awesome. So I go over everything with Vue, how to get started with Vue, Vue directives, just all the real basics of it. And then we create a fully featured app where we have authentication, we're using Firebase, and then we use Nuxt. So I talk about how you use middleware, how we do things on the server, so there's something called server-side rendering, and how you can do that all. It's several hours long. Right now I have it on sale for $37 because of the holiday weekend, and the back-to-school weekend. So check out the course. The link is in the description below, and you can learn all about Nuxt and Vue.js. So I'm really excited about it. I actually just recently upgraded it to the latest version of Nuxt, so it is ready to go. So yeah, check that out. It's in the link in the description. If you buy it, it helps out this channel. So I appreciate it. So let's start with the presentation. Terms you should know as a self-taught dev. So here are the beginning terms that I want to go over. So I'm going to go over these 10 terms, and let's begin. So Boolean. So you're probably thinking, wow, that's really easy. I can't believe people don't know this, but it's true. Some people who are interviewing some self-taught developers don't know what a Boolean is. So this definition is from Wikipedia. So it's essentially you're trying to denote true and false. It's intended to represent the 2 truth values of logic and Boolean algebra. So essentially, is something true or is it something false? And that is called, a Boolean. So you can use that within your app and when you write functions or methods. So that's really easy. Ternary operator, this might be also easy. So this is kind of a nested ternary operator example, which is not always the best. But you can see here, this is a simple arrow function, and we have a return statement that's checking this merit right here. This merit is greater than 100 and merit's less than 150. If it's so, if it's true, if this expression evaluates as true, it returns pass. So then this whole arrow function will return pass. However, if it's false, then it then tries to evaluate this section. And by the way, you can see this question mark and these colons. That denotes this is the expression it's doing, and then the colon is the other value. So it's saying, okay, well, if this doesn't pass, well, maybe it was greater than 150 and maybe less than 200. If that's true, then it goes to second class. This string is passed, and if not, the first class. So this is a simple example of using a ternary. You can kind of do these rather than doing a bunch of if statements. You could do if merit and then else if, or using a switch statement. You can use something like this. I wouldn't recommend more than maybe 2 nested levels like this. You can get really sticky and really confusing if you're using like 3 or 4 levels of nesting in your ternary operators. I don't recommend that, but something simple like this, I think you're probably okay. Functional programming. So this is so we're getting into a little bit more interesting topics here. So functional programming is it's a programming paradigm. You may have heard of object-oriented programming. We'll go back to that in a second. or imperative programming, but this one really deals with changing state and mutable state. And there's a lot of things to functional programming. This is a deep well of things that happen with the functional programming languages. You can make some programming languages like JavaScript. You can write functional JavaScript, although it can be written as object-oriented programming, object-oriented as well. So you have a lot of options. There's some programming languages like Elixir, which is pure functional, or Haskell. But they usually have these tenets to them. Like, for example, they have high-order functions and first-class functions. So functions that can either take other functions as arguments or return them as results is kind of one of the things that functional programming has. They're also pure functions, so they have no side effects. So in other words, like you have a function that you put a value in, and it returns a value out, and it's not going to change. It only changes depending on the input in. It's not going to do any other side effects. It's not going to change any other variables in the app. And so it's predictable that way. You might have used the filter, map, and reduce, where you kind of put in some values and then it returns some values out, but it's not. It's returning those. It's returning the values out. It's not. If you do it on an array, it's not changing. It's not changing the array. It's not mutating the array. It's actually returning a new array. So that's sort of what functional programming is. It's hard to describe, but if you ever ask this in an interview, that you can talk about high-order functions, first-class functions, immutable state, pure functions, I think you'll be on the right track there. And then you certainly jump into a language like Elixir and see how to write programs in Elixir, and it will blow your mind away about all the cool things that a functional programming language can do. And then you can even deep dive into like monads and a bunch of other crazy things that I won't get into. Object-oriented programming, you probably heard this if you've taken any sort of classes in college where they teach Java or C# or community college, or you're just learning these things. But this used to be kind of the default way we learned programming. I don't know, maybe in the mid-2000s was more popular. But you're dealing with objects, and then you have fields and methods. Then you have this kind of inheritance with classes and interfaces. We call it an ISA interface, or ISA. So you can have like a dog, and then you could say like a Shetland sheepdog is a dog, and you have this composition where it has a, where you can have these things connecting up to your classes. So here's an example of like classes in general. So you have each one of these are different classes. So this is like, this student is a thing out there. It's like an object in the world, and it has variables, or we call fields, like name and GPA, and it has methods, which you have getName and setGPA. And then you have circles and soccer players and cars. And then you can have levels of inheritance where classes can inherit from these, and they can also extend from them. And then you can have objects that instantiate other objects, like kind of has-a relationships. So this gets really complicated, but kind of understanding the basics of object-oriented programming, this is usually seen in like Java and C#. You can do it with ES6 with classes in JavaScript, although some people dislike classes in JavaScript. But like if you're in the Angular world, you use tons of classes. This is good to know. So there is something called solid principles. I'm just going to go over two of them. So this is really highly correlated with kind of this object-oriented programming that we're talking about here. And so if you're in the JavaScript world, and like let's say you're using Angular, you're going to use classes. So one good thing to know is the single responsibility principle. And solid, by the way, is an acronym for a set of principles that people think are good to have for object-oriented programs. I'm not going to go into them, but if you want to Google that, Google solid, and you'll see these concepts and more. But this one is interesting. So single responsibility is the concept of a class doing one specific thing, responsibility, and not trying to do more than it should, which is also referred as high cohesion. So in this example, like if you're creating a class, you want your class to just do one specific thing and not to do a bunch of things. So you wouldn't want to have a people class that has a bunch of information about people, or a person class maybe is a better example. A bunch of information about a person, like their job, their career, their age, their name, but then also put in like an email function, not their email, but like something completely unrelated to that person, and then have it inside your class. And so you might hear this term called high cohesion. So high cohesion means to keep similar and related things together, to couple or fuse parts with shared content. So there's this idea that you want high cohesion and low coupling or loose coupling. And so here's a diagram that kind of explains that. So the cohesion part is that you have this, everything in your class is highly related to each other. And coupling means that when your class, you're not tightly coupled with other classes. In other words, you're not relying a bunch of other classes that you're instantiating and using inside your class, that if one of those other classes breaks, then it breaks your class. Rather, if you have loose coupling, it's not as integrated, so you might have maybe less classes inside your class that you're relying on, and that if one of those classes breaks, it won't break your program. So that's just a real quick example of how that works. The OpenClosed principle. In object-oriented programming, the OpenClosed principle states that software entities, classes, module functions should be open for extension but closed for modification. That is such the entity can allow its behavior to be extended without modifying its source code. So this is the idea of like using interfaces and abstract classes. So you have a class and you want to extend it, but you don't want to necessarily always have to rewrite that class every time you want to add more functionality to it, because you want it to be closed. So here's an example of that. So we have this interface called shape. If you don't know what an interface is, it's just it's almost like a contract that other classes have to, once they implement it, have to implement for it. So Miss Shape says that to be an interface, it has to have a draw method. So the circle and triangle at the top here, both would have this draw method inside of it, because it has to essentially adhere to the contract of the interface. So as long as it has it in here, it can use it. So that way you can actually instantiate a shape, and you can instantiate different shapes, either circle, triangle, and that's something called polymorphism, essentially. Now, if you wanted to add a third shape, let's say we have circle and triangle, but we wanted to add like a second circle or a different type of circle, then you still have that ability to instantiate it off the shape here, but you don't have to change the shape. So if you didn't have this open-closed principle, you might have to always change this class here every time you're trying to add a new shape. Instead, we can just extend it and extend the interface or implement the interface. So if you're kind of confused on what I'm explaining here, I would look into interfaces and abstract classes in C# or Java and just try to get an understanding of how you would implement that inside your app, and try to look at the ideas of like, okay, we're using inheritance, and now we're using this, and how it all relates together, and how we can instantiate these different objects. It's also just an easy way of keeping things in your head. Like, okay, this makes sense. Okay, I'm implementing this shape. It has a draw function. This is a circle. This is a triangle. Okay, so let's move on from some of those object-oriented programming concepts to design patterns, which could be object-oriented programming, or it could be many different types of programming paradigms. So one thing you probably heard of is, or you may not have heard of, is the GOF, or Gang of Four. So design patterns really became popular with this book, The Design Patterns, Elements of Reusable Object-Oriented Programming Software. This actually is quite OOP, but it doesn't have to be. And it has this forward by Grady Booch, and it has Erik Gamma, Richard Helm, Ralph Johnson, John Vlizidis. Probably mispronouncing that. So they came up with like these patterns that you can use in your software development world when you're creating programs that just make a lot of sense, and they're reusable pieces of kind of functionality that a lot of programs use. Now, there is a lot of debate on design patterns. Some people think they're useless, or maybe they're overused, or a lot of times people don't understand what a design pattern is, and they try to kind of shoehorn it into situations that shouldn't have it in it. But for the most part, I think if you are going to interview, people might ask you a question: what is a design pattern? You may want to say, hey, I know what that is. It's Gang of Four. It came out in the I don't even know, 1994, and it's these four software developers that came together, and they put these design patterns they think everybody should know. And here are 2 or 3 examples of what they are. That's like a typical interview question you might get. By the way, so I didn't say it's always OOP. I mean, here is one in JavaScript. It's the Learning JavaScript Design Patterns, Adi Osmani. This is a great way to see how he did it in JavaScript. I've heard really good things about this book. So it's not just for, old OOP Java languages. You can certainly implement this in a lot of other places. And don't get this confused. Some people, there's a lot of stuff in the actually design, like graphic design, and sometimes they use the words design patterns, and that's not anything. There's no correlation there, so don't get that confused. So factory. So this is personally the quintessential design pattern is a factory, and everybody talks about it. And it's essentially it's just a way of creating objects without having to specify the exact class of the object that will be created. So you can have a factory that kind of returns objects for you. So that's essentially it. Really simple. So here's an example in JavaScript. Like here's an animal. This is a function. It creates this object. It adds this name, adds this walk, and then you can create, every time you pass in this animal, you can pass in a string into it, and it returns a new object, and then you can just use that object. That's essentially what it is. You can just use this factory method pattern to create these objects. This is really, if you're OOP, you would create classes, and you can have it just return this new class every time you call this new method or function. That's really easy. Dependency injection. So dependency injection is a technique whereby one object supplies dependencies of another object. So in Angular, this is the definition that Angular uses dependency injection throughout, if you're Angular 2+, of course. It's a coding pattern in which a class asks for dependencies from external sources rather than creating them itself. So example would be like an injectable service. If you're using Spring Boot or in Java world, they have a constructor. You can actually do constructor dependency injection and setter dependency injection. I believe constructor is kind of the more popular way to do it, but you can do setter dependency injection. So instead of instantiating it with an object class with new, you can just kind of push it in there and auto-wire it together, and then you don't have to instantiate it, and it makes it much easier to test, and it gets it right in there. So here's an example from Angular. I think this would be more apt if you're especially a new developer. So you can see down here we have this hero service at the top actually, and this hero service is being injected inside the constructor here with this hero service : hero service. So now this can be used throughout this app here, and it says this.heroes hero service.getHeroes. So now you can use this service throughout the app, and it's shared between all instances of the app, by the way. And now when you're thinking shared, yeah, there's probably other design patterns that go into this. Also, I didn't mention one called Model View Controller. A lot of frameworks use this Model View Controller where you kind of separate your different logic, your business logic, from the logic that you use for your databases and the logic you use for your view. That's another one you hear all the time is the MVC pattern, Model View Controller. And that has changed throughout the years too. Okay, so this is essentially what a DI is inside Angular. You add it in here, and you add it into the constructor at the bottom. Singleton. In software engineering, the singleton pattern is a software design pattern that restricts the instantiation of a class to one single instance. So you might also think about, well, this service, could you consider the hero service a singleton? And I do. I think this is a singleton because you can only instantiate it once. Well, let me caveat that. There is ways to instantiate the hero service more than once, I believe, in Angular. But for the most part, you can act it like a singleton, where once it's instantiated once, you can instantiate it again, and that same instantiation is shared between all your different components throughout the whole application, which is the nice thing about a service, because you can share information between a bunch of different places. So that's what you can do with a singleton. So you may have been using a singleton and not even realized it. But basically, it's a pattern as a software design that restricts the instantiation of a class to one single instance. And here's an example just real quickly in JavaScript. Here's the user store. It's an object, has this add, which has an arrow function and a couple different functions in here. You can do object.freeze user store, and then every time you use the user store, you can't instantiate it, or you can't instantiate it more than once. Once it's there, it's there. You can't keep changing it. So it's a singleton throughout the whole app. as it says, restricts instantiation. So that's it. I'd love to hear what you guys think about these terms. Was there any ones that you didn't understand? Is there anything that you want to correct me on, or you think that you know more about? I'd love to hear it in the comments below. Leave a comment below, and make sure you click on that link in the description for my course and check that out. Really appreciate it. Thanks.